Hey everyone, today we're solving the binary subarrays with some problem on LeetCode. We're given an array A of zeros and ones. How many non-empty subarrays have sum S? So here's what the example looks like. The given array is 1, 0, 1, 0, 1. The sum is 2, and then the answer is 4. And here's what those 4 subarrays look like. 1, 0, 1, 1, 0, 1, 0, 0, 1, 0, 1, and then just 1, 0, 1. So the approach I took for this problem can be applied to arrays of not just zeros and ones. This solution can be used for arrays of any integers, positive or negative. Okay? So the way we'll solve it is we'll keep a sum as we loop through the array, and at each element that we get to, if the sum is equal to the sum that we're looking for, then we increment our answer by 1, because that's a subarray from the start of the array to the end, to the current element that we're at, will be a subarray of that sum. And then also we will check and see if we've seen a sum of the current sum minus the desired sum, because the difference between those two sums, those two arrays, will be equal to the target sum. Okay, so let's take a look at something like this example here. So the sum up to this element of all the elements up there is obviously just 1, right? And then the sum to this element right here is 3. Okay? So what we'll do is when we're looping through, we'll say, okay, we'll get to this element here, the total sum so far will be 3. And we'll say, okay, well that's not equal to the sum, so we don't update that. But we will also look and say, have we seen some of the total sum that we have right now, which is 3, minus the desired sum of 2? So do we have a sum that we've seen already of 1? Okay, so this is sum 3 minus 2. We'll look and see, do we have a sum of sum 1? And this subarray right here satisfies that. Okay? So that means that from this element through this element, the element after that is a subarray of sum 2, because the difference of the total sum to this element and the sum at this point in the array right here is equal to the sum that we're looking for. Okay, so that's basically the way it works. So let's go ahead, and you'll see this also works again when we look at it down here. Again, the sum to this final element is 3. Okay, so we'll say, okay, have we seen sum 1? Well, yeah, we have it here, and then we also have it here. So that also, here at this 0, the total sum to the 0 is still 1. So that means all the elements from the next index through the index that we're at will also be a sum of sum 2. Okay? So up here, just check if the array is null. If its length is 0, just return 0. Here we set up a map that keeps track of the sum that we've seen and the list of indices that we've seen that sum at. Then all we have to do is loop through the array, keeping track of the total sum of elements seen so far. At each element, we update that sum with that element that we're at. If the sum that we see is equal to the sum, then that means that the sum from the beginning of the array to the current element is an array of the desired sum. So we update the answer by 1. Then we're also going to check if we have seen a sum of sum minus the desired target. Okay, so if we've seen a sum at some indice of the current sum minus the target sum, then that means that each time that we've seen that sum previously also is a subarray of the target sum. So we add to the answer each time that we've seen that sum. And then all we do is just put this index and this sum into our map. So if we've seen this sum already, then we get the list of indices and we just add it. If we haven't, then we just add a new list with that index, and then we return the answer. Alright, so it works. So that's how this works, and I didn't leverage the fact that this is an array of zeros and ones. There's certainly another formula you could use, another algorithm you could come up with where you don't have to use this map here, and you could leverage the fact that it's zeros and ones. But with this approach, this is called a diff approach, okay? And like I said, you can take this code right here, and this idea of keeping track of the sums that you've seen, and checking for the difference between your current sum and the target sum that you're looking for. And this can be extracted to use for arrays that have any integers in them, positive or negative.